So for this question, we're going to verify that the steady state error for the system is 1.829 for the input of 2 on S, and we're going to assume that the system is stable. This is the same question as what I did in a previous video, but I did it using the error constant method. So this video is going to show that either method will work. Pick the one which you prefer. So if we're going to use the final value theorem, we can write out the equation. So what we need to evaluate is the limit as s goes to 0, and it's s multiplied by the function that we're interested in. So in this case, because we're looking at the error, I'm going to call it e. So e is going to be our error function. Now we can look back at our system and figure out what that is. So r is the input to the system, and that's going to be this 2 on S, and c is the output to the system. And what we want to do is at each point in time, we're going to compare the input to the output. And because we have this unity feedback, what we should find is that at time equals infinity, ideally, the output should match the input. And if it doesn't, that means we have steady state error. So we should be able to find it. So the error is going to be essentially what comes out of this summing junction. It's going to be difference between the input and the output, which comes back as negative. So let's mark this in. E is our error. It's going to be equal to r minus c. So if we want to, we can substitute that in. So it's the limit as s goes to 0, and we can represent the error as the difference in the input and the output. Alright, so we know what r is, that's fine. What we need to evaluate now is c, and we want it in terms of what else is marked in our system. So let's go through and deal with that. The first thing I'm going to try and get is the transfer function for our overall system, which I'm going to call c divided by r. And we can see we have a negative feedback system, so the general equation for negative feedback is g divided by 1 plus gh, where g is your open transfer function, so whatever's on the top line, h is the transfer function of what's in the feedback loop. So in our case, g is just going to be equal to this, and h is going to be equal to 1, since it's unity feedback. So if we were to sub into this, since it's unity feedback, what we end up finding is that this simplified transfer function ends up being the open one, with the addition of whatever's on the top line being added onto the bottom line. So you can go back and look, review some of the older videos I've done if you want to see that happen in practice. So I'm just going to shortcut it. Alright, so for unity feedback, we know that whatever is on the top line of our open transfer function also ends up on the bottom line added in when we close the loop. Okay, let's just make that a bit nicer. S plus 5. Alright, so what we're actually interested in though to replace in this equation is c. So at the moment we have c divided by r. So if we wanted to, we could multiply the r up and we'd end up with c on its own. Okay, multiplied by r. Okay, so let's go ahead and substitute this in here. So r stays here, and c is getting replaced with all this. Alright, so I actually know what r is, but what I'm going to do is factorize it out of the equation first of all, because I'm going to end up with things cancelling. So if I take r outside of this bracket, all that I'm going to be left with is a 1 for this part and this transfer function for the other part. Okay, so that's pretty much all we've got left to do is substitute in r and figure out what the limit is then. So we're told that our input is going to be a 2 on S. So let's sub that in. Okay. Now it's important at this stage we cancel out everything that can possibly cancel out. So we have an S on the top line and an S on the bottom line, which are going to cancel with each other. I don't think there's anything else that we're going to be able to do that with. So I'm going to end up with the limit as S goes to 0. We've got 2 outside our bracket. And what I'm going to do is make this all into... Wait, sorry, I just need to sub in the limit. So it stays the same. So subbing in S equals 0, this is going to become 3 times 5 on the top line. On the bottom line, all the S's are going to 0, so we're going to get 8 times 20 plus 3 times 5. And if you go ahead and work this out, sorry, I've subbed in my limit, so I can drop that. I'm going to end up with the answer of 1.829 from the calculator. And in fact, that is what I was expecting since I was asked to verify that this was the answer. So this is showing that we can get our final answer from either final value theorem, or if you go back and look at one of the other videos I made with the exact same question, you can get it from the error constants as well. So that's all there is. See you in another one.